Right, transformations of graphs. So we're going to do this in general. Right now, I'm going to do a very specific one for you. Let's say that f of x equaled x squared. Well, then what we've got here, we've got y equals x squared plus a. Okay? So, f of 3 equals 9. Y equals 9 plus a. F of 5 equals 25. Y equals 25 plus a. So what you can see is we are always a bigger than we were before. Therefore, f of x plus a is a shift it's like a slide in the y direction of plus a. Okay, that is our first one done. So moving on to our next one, b f of a, f of x even. Okay, let's have a look at a specific one again. So let's say again that f of x equals x squared. Well, now we've got y equals bx squared, right? So f of 2 equals 4, y equals 4b. F of 7 equals 49. Y equals 49b. So you can see that whatever we had here, we've times for our y value. Our y value is times by b. So what this is it's a stretch. Okay, it's affecting the y, so it's a stretch in the y-axis. Scale factor b, and that's the second one. Now I want to point something out to you here. Both of them were on the outside of the brackets. This was f of x plus a, and this was b times f of x. So if it is on the outside of the bracket, that means it's affecting the y. Okay, now we're going to move on to the next one. F of x plus c. Okay, so this one we need to think about things very slightly differently. But let's say that f of x is our nice example x squared again. Then y equals x plus c squared. Now we want to know, okay, when would f of x equal 25? Well, x would need to equal 5 for that. But y to equal 25, well, x doesn't need to equal 5 now because we've already got c, right? So x needs to equal 5 minus c. Minus c. Okay? Same is true for all other values that we put in here. X happens c earlier. In fact, if I give you a purely numerical one, and I give you y equals x plus 3 all squared, right, in fact I'm going to call that g, then g to equal 25, x would only have to equal 2. So it happens 2 sooner, so it has moved 2 to the left. So this is a shift of minus c in the x direction. Okay, now I want to bring your attention to something else. Here we have f of x plus c. Here we have f of x plus a. Now, when we had a plus here, we had a shift. Now it was on the outside, so it was in the y direction. And when we had a plus here, we had a shift, but it was on the inside, so it was on the x direction. So if you have a plus, it's a shift. Same with minuses. If you have a minus, it's also a shift. Okay? Last step. F of dx. So, I'm going to say that f of x equals x squared again. We're now going to have y equals dx squared. Okay? Now, in order to solve this, we're going to look at specific values. So, I want f of x to equal 36. For that to be true, I need x to equal 6. Okay? Now, if I want y to equal 6, right? I need dx to equal 6 or x to equal 6 divided by d. It's going to happen d quicker. And again, if I put in g, I'm going to put that one in as 3x squared. Then if g equals 6, we only need x to equal 2. So this one's happening 3 times quicker. Therefore, this has been a compression. Okay? So, we have a compression in the x-axis. Of scale factor d, or we can write it as a stretch. Sorry, my pen's playing up. A stretch of scale factor 1 over d. Okay, now we have dx here, and we've seen it's a stretch. It's scale factor 1 over d, but it's a stretch. And up here, when we had times b times f of x, it was also a stretch. So we can see that if it's a multiply, it's a stretch. Okay. That is the general rules done. Now, you may have noticed that here you could have timesed it out and you could have got 9x squared, and then actually it would have looked far more like this one does. Now, that's true, but only because of this style of problem that I've chosen. If I'd done, say, a trig problem with a sin x, which would have been a lot more complicated, you wouldn't be able to just bring the number out like that. So it's not really worth worrying about too much. All that actually means is that sometimes for certain shapes a stretch in y of one thing could be exactly the same as stretching an x by something else. Okay? So last point, just to bring these all together, if it is on the outside of the bracket, like these first two, it affects y. If it's on the inside of the bracket, like the second two, it affects x. If it's an addition or subtraction, it's a shift in that direction, just like that one was and that one. And if it's a multiplication or a division, it's a stretch in that direction. Okay? It's often quite useful as well to put in numbers, just like I have here, with my numerical solutions, just to attempt to work out, hang on, which direction is it going. Okay? Hope that makes sense.